Welcome to Coach Actor's Math. Today we are going to be talking about parallel lines and transversals. So, starting off with some definitions, parallel lines are lines in the same plane that do not intersect and have the same slope and are equidistant apart. Okay, so if I want to draw, or in this case sketch, parallel lines, I'm going to go ahead and draw two lines. And I know that by definition, they will never touch each other, because they have the same slope, they go in the same direction, which means that every point throughout my two lines are going to be equidistant from each other. The way that we mark lines as parallel is you'll see two little arrows in the middle of the line to show that they are parallel. They are traveling in the same direction, often referred to as railroad tracks. In real life, that is a great example. Second definition, skew lines. Lines in the same plane, lines that are not in the same plane, they are not parallel and do not intersect. So a great example would be if I talked about this line right here that I'm drawing and this line right here made by the ruler. Notice they are two lines, they will never touch each other. As the ruler is going into the camera right now, it will never touch the line that is traveling horizontally across my paper. Because they are not in the same plane, they will never intersect. However, these are not parallel lines because they do not have the same slope. So that is skew lines as we're going forward. Know that parallel planes is the same type of concept. So when I talk about parallel planes, that would be like me taking and picking up this piece of paper, and now I'm holding two sheets of paper. One sets on the desk and one I'm holding just above it and it's floating above it. That is going to be parallel because it is still traveling in the same direction. It's still equidistant at all points, but they are not touching each other. Okay, so when we denote that, we'll just draw ourselves two planes. Okay. And usually if they're going to ask us those planes, they're going to tell us that they are parallel. They might go ahead and mark the edges of them and tell us that the sides are parallel on the plane, and because the sides are parallel, that means the plane is parallel. Because officially, there is no side to a plane, it goes on forever. So, let's look down below. Look at example 1. Use the figure below to answer the questions that follow. Part A, what lines are parallel to line AB? So I'm looking for things parallel to line AB. If it's parallel, it must be on the same plane, which in our case happens to be a face of my triangular prism, such as line DC. Or I could go to the back edge here and go line EF. So those are two options when we talk about parallel lines to AB. In this case, the only two options. Everything else is either going to intersect it or be skew. Which leads me to the second part. What are other sets of parallel lines? Well, I can look right here and say ED is a line. ED would match up with CF. Notice they're on the same plane because they're both a part of DEFC. And notice that they are traveling in the same direction, which is what makes them parallel. They have the same slope. Another option, DA, would be parallel to CB. I could say EA is parallel to FB. Now, the one thing I haven't put on here is the parallel sign. When we do the parallel sign, like we talked about earlier, parallel, we look at railroad tracks. So we can just put two lines in there like that. That stands for parallel. That is my symbol for parallel. That means that those two lines are on the same plane and traveling at the same slope. Name a pair of skew lines. So let's go back to our first segment, AB, first line AB that we talked about. AB is skew to, well, AB will never touch and is not parallel to ED. And at the same time, it is also skewed to CF. So, those are two options for you as you are looking at skew lines. Looking at a parallel plane, I'm going to go ahead and start with plane ABC. And I'm going to say plane ABC is parallel to plane. Well, here's where we run into our problem. Plane ABC is not parallel to any plane. So I would put a line through that and say it is not parallel to any plane. Plane ADE would be parallel to plane CFB. So ABC is not parallel to any other plane because it intersects at DC with the plane on the back. It intersects at AB with the plane on the bottom. So plane ABC cannot be parallel. Plane ADE, this triangle on this side, my face on this side, can be parallel to CFB. So those two planes would be parallel. Looking at the next page, I went ahead and started us off with some parallel lines drawn on our examples. Go ahead and take care of that now if you would please. Pause the video, take care of that for all of your boxes. All right, looking on. A transversal is our next definition. A transversal is a line that intersects two or more lines in a plane at different points. Again, I'm on a sheet of paper, which means that it's on the same plane. I've got two lines, and I'm going to draw a line right there. That would be my transversal. Okay, that is my transversal right there. It is a transversal because it's crossing two or more lines in the plane. The plane is the paper at different points. There are two separate points where it is crossing. So what I want you to do is go ahead and at this point add a transversal to every set of parallel lines you drew below. Please also take a moment to mark those lines as parallel by putting the two arrows on there to show that those lines are parallel to each other. Take that time now. All right, so let's look on to the next piece. Our next piece talks about alternate interior angles. Well, the word interior tells you they are on the inside, and the word alternate tells you that they are on opposite sides. Okay, so if I want angles on the inside, they have to be between my parallel lines, and on alternate sides, I could say these two angles right here are on the inside of my parallel lines, and they are alternate each other. Alternate exterior angles must be on the outside of parallel lines. So since it's on the outside of parallel lines, and it's alternate, again, on opposite sides of my transversal, I could mark these two angles right here on opposite sides of the transversal and outside my parallel lines. We would call those alternate exterior angles. Same side interior angles. Same side of the transversal, interior, inside my parallel lines. Go ahead and mark two angles right here. Those two angles are same side interior angles. Same side exterior angles. Again, same side of the transversal. Exterior means outside. So I'm going to go ahead and mark those right here. They're on the same side of my transversal. They are outside my parallel lines, which makes them same side exterior angles. Corresponding angles. Two angles that are in the same position relative to the lines and the transversal. So, say I mark this in the top right corner in reference to the top line and the transversal. Well, if I cover up the bottom piece and I look at those four pieces, it intersects, or the angle I'm talking about is in the top right corner. So now when I cover up the top half and only look at the bottom half, I want the angle I'm talking about to be in the top right corner. And those would be considered corresponding angles. So, now that we've kind of got some definitions worked out, I want you to take a minute, pause the video, and look through example 2. It asks you to figure out below and classify each angle pair, determine the transversal that forms them. So you're going to tell me angle 1 and angle 5 in this case would be corresponding. And the transversal that 1 and 5 both touch would be line C. So go ahead, pause the video for just a moment, and try the rest of these examples using the definitions we just completed. All right, let's look at it. 4 and 6. 4 and 6 are on opposite sides of line C. Well, they're opposite sides of line C, so that means it must be my transversal. They're on opposite sides, which means that it's going to be alternate. And because they are on the inside of line A and line B, we're going to say alternate interior angles. I'm just going to put the angle symbol there with an S so that you know that's what it stands for. Looking at 4 and 10. 4 and 10. Notice 4 and 10 both touch line A, so line A must be my transversal. They are on opposite sides, which makes them alternate. And because they are outside of C and D, I'm going to call them alternate exterior angles. 2 and 9. 2 and 9 are on the same side of line A, which is my transversal. 2 and 9 are also both on the inside of line C and D. So we are going to say they are same side, interior angles. 4 and 12. 4 and 12 both touch line A, which makes it my transversal. 4 and 12 are both on the same side, but they're not both exterior and they're not both interior. So I look at it this way. I cover it up. It's the bottom left. It is also the bottom left, which makes them corresponding angles. 3 and 9. 3 and 9 are alternate interior angles. 2 and 7 are alternate. Jumping ahead on you. 3 and 9 are going to have a transversal of line A because both angles touch line A. 2 and 7 are going to have line C. As both angles touch line C, they are going to be alternate exterior angles. 3 and 12. Again, transversal they touch is A. They're on the same side, and they are on the interior. So we're going to say same side, interior angles. 1 and 7. 1 and 7 are both on line C, which makes it the transversal. 1 and 7 are both exterior, and they are on the same side. So we're going to say same side, exterior angles. Thank you for watching Coach Ike's Math. I hope you have a great rest of your day.